So the first thing we're going to look at today is in 3.6, they're going to give us a problem where it says find a standard equation of any parabola that has a vertex at some point. For the most part, when they're saying it's going to be any equation or any parabola, that means we're still going to have an extra letter in there somewhere. So it might not have all numbers filled in. For the most part, when they say standard equation, it's going to be one of our main forms, but most of the time, they mean vertex form or transformation form, that y equals a x minus h squared plus k. This kind of guy. We are very, 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 can almost guarantee never going to have a B transformation in these. Like when we're writing the equations, we shouldn't see a lot of B. And if we do, I assigned you the wrong problem, so we shouldn't have a B transformation. So when we have something like this, we're given our vertex at -3, 1, and we want to fill in what we can for this formula. So what pieces do we know? H and K. Because our vertex is always at the point H comma K. So if we fill in the things we know, we're going to have our y equals, if you want to give it an f of x name, valid. A x minus h. What's our h? -3. So if we have x minus -3 plus 3 squared plus k plus 1. So if we're writing for any equation that goes through that vertex, I could have any a value here and it would have the same vertex. So whenever it says any equation with these conditions, your a is probably still going to be a letter A. By the end of the day. But on these ones, when it's just write the generic, anyone that works for this, we're just plugging in the vertex that we've got. We don't have any more information, so we couldn't figure out A even if we wanted to. Same vibe on this one. So we're going to write the standard equation for any parabola that has a vertex at 0, -2. So see what we can come up with for that one. Oh, that's right. Senior game.
Teachers, at this time, please release seniors to the north gym. The north gym. Seniors to the north gym. If you have all senior classes or all senior students, you are expected to attend with them and actively supervise. Thank you.
Seniors, if you're gonna go, totally fine. I'm gonna have you quiz on your way out. That's the other reason we're doing that. Because then you guys don't have to come back and try and make it up. We got you back here. That's what you want. Huh?
What is senior?
Oh, they're gonna go to college. And if you swing by later, I'll have all you guys. Oh, you already got your homework. You're right. All right. Schmurp. Good one. All right. So what would our equation be for this? You can put the -0 if you want. We don't need to. If you put it like this, absolutely valid. If you put it with the -0, also valid. It doesn't hurt. But then we also have our -2. So this gives us our any equation. Okay, questions on these ones? Careful with the child. Marshmallow. All right. The next thing they're going to do is they're going to give us one in standard form and ask us to write it in our vertex form or transformation form or standard form. And we have a couple of options when we go through that, several of which we've worked with before. We could come through and complete the square. We've done that. So one option for getting it into vertex form is completing the square. Just like we did for circles. But I know that is unpleasant and uncommon. There is an easy option for how to do it. And it's finding our axis of symmetry. And then our vertex from the axis of symmetry. So completing the square, absolutely valid. I would need my x's. I'd want to take the -1 out. And we have to just be really, really careful. Or we can find our axis of symmetry, which has that formula. It's like the very beginning of the quadratic formula. Minus b over 2a. That gives us the x value of our vertex. If I know the x value of my vertex and I find my y value of my vertex, I can make vertex form. So completing the square absolutely works. It is the hard way, but it works. Say it again? Axis of symmetry. Sorry, I'll write it out. I just take the lazy way a lot of times. Axis of symmetry. So we can find the x value of our vertex by taking the opposite of b. And our b is our -4. So the opposite of -4 over 2 times our a. And our a is -1. Well, that's the same thing as if I had +4 over -2. What does that simplify down to be? -2. So for my vertex, I know that my x is -2. Because that axis of symmetry, that vertical line that goes through the center of my parabola, goes through the vertex every single time. How could I find the y value when x is -2? Plug it into the equation. And shoot, we can put it in a calculator. We can use calculators. We've got tools at our disposal. Build the sucker in. I was thinking. There we go. Boop. When we have our negative times our -2 squared -4 times -2 -5. Just typing in the whole equation, substituting x with -2, we get -1. So our vertex is at the point -2, -1. Now I know the point. We're going to put it in our vertex form. What's up? What did I lose you?
You said the -2 into the
Into this equation. No, you're right. So we'll have a negative in the front. That'll fix it. Cool. So now we know we can do this exactly like the way we did the last ones, where we have our x minus h. So x minus the x value of a vertex minus -2. So +2. And then plus k minus 1. But do we know the a value?
Yes.
What's our a value? The same a value is here. The a value is the a value, no matter what form it's in. Even if we have that a from different places, the a from our ax squared is the exact same a as the a in front of our x plus 2. Oh, squared. I forgot the power. So our actual equation on this guy is going to be our y equals -1 times our x plus 2 squared minus 1. And that's our answer. That's too dark. There we go. I just want to be able to see through it. So if we have standard form, I have my a value. It's right there. You can choose to complete the square, where I would need to factor out a -1 out of my x squared and my 4x to add a number in. As long as we make sure we add the same thing to both sides, totally fine. Just got to be careful. This is honestly less work than completing the square, and completing the square usually makes our heads hurt. We're going to practice this again because it's weird. So let's put this one into our vertex form or transformation form. So first thing I'm going to do is I'm going to find that axis of symmetry. First thing I want to do is I want to find that axis of symmetry. Again, if you like completing the square, go for it. Complete the square. It absolutely works. But the easy way is to find our axis of symmetry and find our vertex. But you can do it whichever way you want, whichever way works better for you. Our axis of symmetry is our -b over 2a. If we think about our quadratic formula, that would be the opposite of b right before the plus or minus with our same denominator of 2a. That's what that is. So our x equals the opposite of our b, which is the -6. So put a line underneath. Over 2 times our a, which is our -3. It's really important that we don't forget the opposite of b on the top or the 2 in the denominator. Both pieces are very, very important. So our x value of our vertex is going to be our opposite of -6. So +6 over 2 times -3, which is -6. I'm good at writing. So where is our axis of symmetry? -1. So for our vertex, we know that the x value is going to be at -1. We can find the y value. We can substitute that in. You can use a calculator. You can do it by hand. It'd be really, really clear. What do we get when we substitute in that -1? What do we get as our y value for our vertex? Yep, we should get -2. And you can just straight up type this in the calculator, or you can do our -2 squared, which would be +4, times -3, so we'll have -12. -6 times -2, which gives us a +12. Now my brain stopped. Oh, plugging in the -1, not the -2. There we go. Haha, I was like, wait, that didn't work. So our -3 times 1 would be -3 plus 6, +3, -5, -2. Got it. Sorry, I said things backwards. So when we're writing this into our standard form, into our transformation form, our y equals, what's our a? -3. And then we're going to have our x minus the x value of our vertex, so minus -1, which becomes a +1, squared, plus k, plus the y value of our vertex, -2. So you can absolutely do this with completing the square. Again, it absolutely works 100%, totally fine. definitely have her and formula. But this is the easier way. Questions on this one? All right, the next kind of questions they give us are like this. So we've got using the quadratic formula to find our zeros, find our roots. We want to find our maximum or minimum, which means we want to find our vertex, and we want to give a sketch. So it starts out very, very similar. We can find our vertex, we can find our zeros with the quadratic formula. It doesn't matter what we do first. So on this one, it does specifically tell us to use the quadratic formula. It also won't factor, so we kind of have to. So if we don't know it, that's our opposite of b plus or minus square root b squared minus 4ac all over 2a. So a lot of these pieces we already know, because we could find our roots just by substituting in those values, our zeros. So we're going to have the opposite of our b being 4, plus or minus the square root of our b squared minus 4 times our a of 1 times our c of 9 over 2 times 1. I do highly recommend filling in the values before you start trying to simplify stuff. It is very, very easy to get things mixed up, especially when you are simplifying at the same time as when you're filling things in. It's very easy to get them confuddled. So be really, really careful and be very, very intentional with which pieces we put in which spots. Because as we simplify this, we should get that our x equals -4 plus or minus the square root of 4 squared gives us 16. 4 times 9 gives us 36. So we're going to have our -4 plus or minus the square root of -20. So we don't have any real roots. We have imaginary roots. And we could simplify that. Like square root of -20, we'd have I square root of 20, which is 2 root 5. So we could simplify that in a number of ways. But what we really care about is that we are not going to have any real roots here. These are both imaginary roots. So when we are doing a little sketch, we should not cross our x-axis at all. They're imaginary roots. Where is our vertex going to be for this one? We have several of the pieces actually already have filled in. Because our axis of symmetry are these guys. So this is the pieces we need for the axis of symmetry for that x value of our vertex. So we're going to have our -4 over 2. So what's the x value of our vertex? -2. So our vertex is going to be at the point -2, something. What is the y value on our vertex? I heard two different answers. 5. So we take our -2 and throw it through our equation. So I know if we were to try and sketch this out, my vertex would be at -2, 5, so it would be somewhere up over here. -2, 5. And we are not facing the x-axis. We will not intersect the x-axis. We have no x-intercepts. My a value is positive, so we can really tell this is going up over here. It's going to go up like that. We're not going for a super duper proper graphing. If you want to, you absolutely can. From our standard form of an equation, we can actually get our y-intercepts, because we're going to have a y-intercept at our c value, so we know it's going to hit our y-axis at 9. But again, that's not something we necessarily need to do.
What is the other thing with the first part we just did? Like,
Oh, if we had roots, we'd be able to put them on here.
so there are no roots.
So since we wound up with imaginary numbers, it means we have no real roots. But if I got like 3 and -7, I could plot those up. So it's just kind of mushing everything that we've done with quadratics kind of ever together. Let's see the next one. Okay, so finding, if we found x-intercepts, we'd be able to plot those on here. If we got our vertex and our x-intercepts, that's a very decent sketch. If we have our vertex and I know I don't have x-intercepts, I got a decent sketch. It's just kind of giving us the vibe. The next kind of question is very much like the very first one we did today, plus a little bit more. So we're going to find the equation for a parabola that has a vertex at 0, -2. Start with the any equation for a parabola with a vertex at 0, -2. So for our any equation for a parabola that has a vertex at 0, -2, we actually kind of did that one already. That would be the very second one we did, where we have our y equals a, and you can put your x minus 0, or we could just put our x squared minus 2. That would be any equation that has a vertex at 0, -2. Any equation. So if we start with the any equation, then I go, but I don't want any equation. I want this specific one. Well, what we can do with that is now I know an x value that's tied to a y value. So we can substitute those in to figure out what a needs to be. So if we have our any equation, I can solve and find a by taking my 25 equals a, my x being 3 squared minus 2. So if we know an x and a y, I can substitute those in for x and y. At this point now I only have one letter. I can solve this around to figure out what a needs to be. What do we do first? Oop, where did I lose it? I substituted in place of the x and y over here. Because this is any equation with that vertex. It could be very, very tall and skinny, it could be really, really wide, it could be upside down, I don't know.
Just
Oh.
slow it down.
Yep. We're going to take that point and substitute it into our any equation, and that'll let us figure out what A needs to be. So what can we do first over here? Or what should we do? Yeah, we can square the 3. So we've got our 25 equals A times 9. And then minus 2. We can add 2 so that we get 27 equals 9A. I'm just fixing that because it makes my brain hurt. Divide by 9. So what does our A equal? 3. So now I know what my A should be. I no longer need the any equation. I can get the exact equation that we wanted. So our Y equals 3 times our x squared. If you want to have the parentheses, more power to you. If not, it's also totally okay. Minus 2. You can have the parentheses or not. It's vertex form. Yes, dear.
One question, what does parabola that has a vertical axis mean?
It's going to be U-shaped as opposed to being this way.
Oh, so this means
It just means it's right side up. It's an absolutely normal parabola. Nothing weird. They're being bizarrely specific every now and then. If we had it as a x equals y squared, that's one of these. We're not going to see those. They're just being extra and saying things that are important in like 3 years when you continue your math. Because yes, it's important, but not for a minute. Questions on this one? Oh, I have to practice another one like that. So here's another one, very, very similar. We're given a vertex, and we're told it has an x-intercept of 0. And y'all just all started instantly right. I'm gonna let you cook for a minute. Here. Okay. So I saw you guys flying on this. I love it. So what is our any form for the vertex of 3, 0? Or sorry, 3, 1. X minus 3 squared plus 1. So we start with our any parabola that has that same vertex. Then if I know we have an x-intercept of 0, what point do we know it goes through? 0, 0. Because our x-intercept happens when y is 0. But we also know x is going to be 0 there. So we can take that point and substitute it in to figure out what a needs to be. So we're going to have that our 0 equals a times 0 minus 3 squared plus 1. So be real careful here. It's really tempting to have a lot of things like zeros. They go away. Because we need to simplify differently. So be really careful when we're simplifying, because this should be our a times 0 minus 3 gives us negative 3 squared plus 1. So we can have our 0 equals a times 9. I'm going to have it as 9a, just because a times 9 makes my head hurt. So what can I do from there? Subtract 1 from both sides. So we're minus 1 from both sides. So we get minus 1 equals 9a. I did. Too much enthusiasm on my ponytail went. Minus 1 equals our 9a. So what does our a equal? Negative 1/9 equals a. Our a's can be fractions. Our a's can be positive or negative. All kinds of stuff. So our final equation on this is going to be our y equals negative 1/9 x minus 3 squared plus 1. And that puts us in a very good place for what we need to do time-wise. I should be able to get to there. Come on. Okay. Questions on this one? When we're looking at section 3.6, especially for homework questions in there, the last couple of them that have pictures, we're going to practice with tomorrow. I have the pictures. We'll do those tomorrow. Just like when you see things like this, we're going to work with stuff like that tomorrow. I promise. So on 3.6, partly because of time, partly because it was getting repetitive, I'm cutting a few of the questions. So don't. That's for 3.6. It is. Yeah, I've got it listed as due Monday. We're going to talk about the last couple of kinds of questions tomorrow. I'm going to give you guys the quiz. You're turning it into me tomorrow. Bring it back. Okay? But that way we have a little bit of time. I'm not close I'm pretty nice about it. I always give at least a day of wiggle room, so when it says due 29th, I give it to the 30th because that's yes. If we wind up with a bunch, then we have a little conversation. So we gotta work on the on-time. Here is the quiz. Bring it back to me. I also have posted the answers for everything I passed back, including homework 3.5. So as we're looking at things, if you want to turn your homework 3.5 in tomorrow, I am 100% okay with that, so that if you want to look at it while you're looking at the quiz, valid. So if you are one of the people who would like to look at 3.5, so you can use what you did and you want to take it back, I'm 100% okay with that.
What does this have to do